Here are the key points from the provided text. 1. Creating a scientific coding environment. Goal: build a long-lasting scientific coding environment. 2. Installation of Anaconda. Anaconda, a Python distribution compatible with Windows, macOS, and Linux, provides access to essential science libraries. 3. Using Conda package and environment manager. Conda helps keep projects organized and up to date. 4. Familiarization with popular coding tools. Jupyter Qt Console, Spider, Jupyter Notebook, Jupyter Lab. 5. Purpose of coding tools. Tools help write code, run code, and review output. Summary available in Table I1. Terminology explanations in the Terminology sidebar. 6. Jupyter Qt Console executes commands in IPython interpreters. Displays results immediately. Useful for data interaction, visualization, and learning Python. 7. Jupyter Notebook. Web application for creating and sharing documents with live code, equations, visualizations, and text. Popular in data science for exploring data and creating reports, presentations, and dashboards. Jupyter Hub, cloud-based service for multiple users like students or research groups. 8. Spider and Jupyter Lab. Both are integrated development environments, IDEs. IDEs provide a set of tools for programmers. 9. Important terminology. Definitions and explanations of terms used in Part 1. Here are the key points from the provided text. Debugging. 1. Definition: a process for finding, isolating, and resolving bugs that prevent proper program operation. 2. Tool. Usually performed with a debugger. 3. Functions. Runs the program under controlled conditions. Tracks operations step by step. Halts the program at specific points. Skips over parts. Displays memory content. Shows error positions causing crashes. Extensible. 1. Definition: a software principle indicating if a tool can support future growth. 2. Example: Jupyter Lab is an extensible environment. 3. Extensions. Add-ons providing new interactive features. Examples: Jupyter Lab LaTeX, LiveEdit LaTeX documents, Jupyter Lab Plotly, render Plotly charts, Jupyter Lab System Monitor, monitor resource usage. Custom plugins can be written for specific projects. IDE, Integrated Development Environment. 1. Definition: a coding tool integrating specialized utilities into a single environment. 2. Components: text editor, debugger, code autocompletion, error highlighting, file managers, project managers, performance profiler, deployment tool, compiler, etc. 3. Benefits: increases programmer productivity and manages large projects with interrelated scripts. 4. Drawbacks: resource-intensive and may be complex for beginners. Introspection. 1. Definition: ability to determine the type of an object and check its properties at runtime. 2. In Python, an object has attributes and methods. 3. Usage: code introspection examines objects and provides information dynamically. 4. Feature: hovering over an object can display a pop-up with its type and usage tips. Kernel. 1. Definition: the core computational engine of an operating system. 2. Function: manages disks, tasks, and memory. 3. Role: acts as a bridge between applications and hardware-level data processing. Profiling. 1. Definition: analysis measuring time or memory required for a program or its components to run. 2. Purpose: optimize code and improve performance. 3. Tools: built-in profiling tools in IDEs like Spider. Qt. 1. Definition: a widget toolkit for creating graphical user interfaces and cross-platform applications. 2. Platforms: Windows, macOS, Linux, and Android. Terminal. 1. Modern usage: refers to a terminal emulator providing a text-based interface for commands. 2. Alternative names, command line interface, CLI, command prompt, console, shell. 3. Examples. Windows, command prompt, command exe, for DOS commands and server connections. macOS, terminal for Unix commands and machine access via ZSH. Unix, sterm for running bash or other shells. 4. Functions. Access information/software on central computers. Easier manipulation of files and folders. Automate workflows, run Python programs, and Anaconda operations. Terminals are not very user-friendly, but they allow access to information and software that sometimes is available only on a central computer, such as a file transfer protocol, FTP, server. Manipulating thousands of files and folders in the operating system is also easier in a terminal than in a graphics window. You can automate and expedite workflows on your computer, saving you time and aggravation. Additionally, you can run Python programs from a terminal as well as a lot of Anaconda operations as an alternative to performing them with the Anaconda Navigator GUI. Here are the key points broken down. Anaconda overview. Anaconda is a popular data science platform. Provides access to a large collection of science libraries. Installation process covered for Windows, macOS, and Linux. Verification involves launching Navigator, Anaconda's GUI interface. Features of Anaconda. Includes tools for coding and dataset management. Contains the Python language and pre-written programs called packages. Navigator GUI for easy interaction. Nucleus, a community learning and sharing resource. Content is created and maintained by various organizations and distributed through Anaconda. Understanding packages. Packages are collections of modules, which are single programs for specific tasks. Example, image manipulation modules grouped into packages within the OpenCV library. Terms module, package, and library are often used interchangeably. Packages can also refer to units of distribution containing libraries, executables, or both. Managing dependencies and environments. Scientific packages often require specific versions of other packages and Python. Anaconda uses Conda, a binary package and environment manager, to handle these dependencies. Conda installs necessary dependencies and alerts about missing ones. Allows creation of Conda environments to avoid package conflicts and ensure reproducibility. Environment creation covered in Chapter 2. Anaconda.org. Access to a package management system for finding, storing, and sharing notebooks, environments, databases, and packages. Supports both Conda and PyPI packages. Facilitates collaborative work on the cloud. Allows building and sharing new Conda packages using Conda Build. Here are the key points broken down. Anaconda overview. Developed and maintained by Anaconda Incorporated. Offers a free Anaconda distribution and commercial versions. Official documentation available at Anaconda Documentation, https://docs, anaconda.com/anacondaerg. Language support. Distributes our programming language. Conda manages packages, dependencies, and environments for languages including Ruby, Lua, Scala, Java, JavaScript, C/C++, Fortran, and more. Focus of the book is solely on Python. #### installation requirements. Requires about 5 GB of free hard drive space. Miniconda, a minimal installation, requires around 400 megabytes. No need to uninstall existing Python installations or packages before installing Anaconda. Troubleshooting resources. Troubleshooting guide at Anaconda Troubleshooting, https://docs, anaconda.com/onad/user-guide/troubleshooting. FAQ at Anaconda FAQ, https://docs, anaconda.com/anaconda/user-guide/FAQ. Follow instructions in the installation wizard if there are divergences. Anaconda Navigator. Desktop GUI for managing Anaconda. Provides a point-and-click interface for launching applications, searching for packages, managing Conda environments, channels, and packages, and accessing training material. Available for Windows, macOS, and Linux. Launching Navigator. Windows. Start menu shortcut. Linux/macOS. Terminal command Anaconda Navigator. 4star.sh installer. macOS. Navigator icon in Launchpad for GUI installer. Navigator Home tab. Initial window includes app tiles such as Jupyter Notebook and Spider. Tabs include Home, Environments, Learning, and Community. Base root. Environment is the default starting point. Application tiles. Square tiles for applications like Datalore, Spider, command prompts. Each tile includes a logo icon, app name, description, and a launch or install button. Gear icon for managing apps, install, update, remove, or install specific versions. Dependencies are automatically installed with apps and shown in a pop-up window. Updating Navigator. Home tab may not reflect changes made via Anaconda prompt command line. Refresh button updates the Home tab. Anaconda Nucleus. Link available on the lower left of the Home tab. Sign-in button for accessing Anaconda Nucleus and repositories like anaconda.org. Here are the key points broken down. Environments tab overview. Access the Environments tab by clicking the Environments link beneath Home. Manage Conda environments and install/uninstall libraries from Anaconda, CondaForge, and other sites. Base root. Environment is initially visible. Creating and managing environments. Create new environments using the Create button. Additional buttons for cloning, importing, removing, and possibly backing up environments to the cloud. Only one environment can be active at a time. Activating a new environment deactivates the current one.